is example 2 of the exponential functions lab. We have the following function, f of x equals negative e to the x plus 3 plus 10. For part 1, we want to determine what transformations we can use on f of x equals e to the x, which is a function we are already more familiar with, to get our function f of x equals negative e to the x plus 3 plus 10. So we'll look at if there's any reflections, any horizontal shifts, any vertical shifts. So starting at reflections, there's two types of reflections. There's a reflection about the x-axis and a reflection about the y-axis. If there's a reflection about the y-axis, then our whatever's enclosed with our x would be negative. Our x would be negative. You can see, however, that our x from here to here is positive, so there is no reflection across the y-axis, like in example 1. If there's a reflection across the x-axis, however, our function here would be negative, and we can see here that there's a negative here, so there is a reflection across the x-axis. Moving on to horizontal shifts, we can tell if a function moves left or right based on what is enclosed with our x value. So you see from here to here that what is enclosed with our x value is a positive 3 in the exponent. And when a value enclosed with our x is positive, if it moves positive 3, it actually moves the opposite direction. So here it's telling us, when it's a positive 3, that the graph itself moves left 3 spaces. So there's a horizontal shift left, or negative 3 units. If this was a negative 3, if this was x minus 3, it'd be actually to the right 3 spaces. So it's either negative 3, or we can say left 3. For vertical shifts, we look at what's added to the function after all, or minus after all, and we see this 10. So we have this right here, and we added 10. And so what this does is it shifts our graph upwards 10 spaces. So we go up 10 spaces. And now we're going to see what those transformations look like visually. So here we have y equals e to the x. And if we have y equals negative e to the x, for example, it shifts it over the x-axis, as you can see. And then with our exponent, we have a plus 3, which will move our graph to the left 3 spaces. If we get rid of this negative, you may be able to see it. But you can see now that we've actually moved left 3. So we still have that reflection. And then we're going to move upwards 10. Upwards 10. So we've moved our graph upwards 10 spaces. And so this function in black is our function in red transformed.